Okay, in this video I will continue the explanation of coordination reaction, and more specifically I want to talk about the exchange reaction which can occur between two donor-acceptor couples. So if I consider two donor-acceptor complex couples, for example ML-M having KD and M prime L M having also KD prime. So both couple will exchange L, and we will have exchange of L between both couples. So as we are exchanging L, so we make PL scale. I want to put my couples over the scale according to the PKD values. So I have PKD prime and prime L donor and prime acceptor, PKD ML donor and M acceptor. So as if I add L plus M, it will give me ML, L plus M prime, it will give me M prime L. So the dominating reaction which can occur between these two couples is between the more acceptor and the more donor. So M prime L plus M, I will have M prime plus ML. Here I exchanged L between two metals, M prime and M. K of the reaction, if we want to develop K of the reaction, K is product over reactant. As I exchanged L, so I want to multiply by L and divide by L. As when we exchanged H plus, we multiplied by H plus and we divided by H plus. So here I want to take the couples M prime L, it's K prime D, and M times L over ML, it's KD. So I have K, it's equal K prime D over KD. As K prime D, it's 10 power minus PK prime D, and KD is 10 power minus PKD. Thus I will obtain a formula of K which is equal 10 power PKD minus PK prime D. PKD, it's for the couple having the acceptor, so it's PKD acceptor, minus PK prime D, it's the PKD of the donor. So the general formula of K is equal 10 power PKD acceptor minus PKD donor. So anytime that we have exchange of ligand between two metals, so we have a reaction like acid-base reaction between two couples, the K of the reaction can be applied directly as K equal 10 PKD acceptor minus PKD donor. As we have exchange of ligand between two metals, also I can have exchange of metal between two ligands. So if I have so if I consider two couples MLL and ML prime L prime, each couple بيعمل exchange ل M. So كل couple has also its own KD. So over the scale, as we are exchanging M, so we have PM. So over this PM scale, I want to put the PKD for both couples. So PK prime D, PKD. Then we put the acceptors. M plus L will give us ML. M plus L prime, it will give ML prime. So the dominating reaction will occur between the most acceptor and the most donor. So the reaction will be ML prime plus L, and we will have, it will give us the product L prime plus ML. K of the reaction we can apply directly, PKD acceptor minus PKD donor. The acceptor here, it's L, so it's 10 power PKD minus PK prime D. So we have two kinds of exchange reactions: exchange of metal between two ligands and exchange of ligand between two metals. I want to consider now an exercise. If we have 1 liter solution of a mixture composed of Ba2+, which is metal, and Y4-, which is ligand of 0,1 concentration for each one. We need to calculate the exact composition at equilibrium and PBA2+. Given of the exercise, it will be pKd. As we have in the medium metal and ligand, so the kind of the reaction is formation of a complex. So Ba2 plus Y4 minus will give us the complex BaY2 minus, 2 plus 4 minus, so the charge of the complex is BaY2 minus. K of the reaction, as we are talking about formation of the complex, so K it's equal 1 over Kd, or it's equal Kf. So 10 power 7.8. So at the beginning, Ba2 plus is 0,1 and Y4 minus concentration is 0,1. At equilibrium, both will be negligible, and we will have formation of Ay2 minus 0,1 molar. So at equilibrium, what we have in the medium, we have Ay2 minus. To determine the exact composition, Ba2 minus will have the dissociation of Bay2 minus as equilibrium of control. So Ba2 minus will give us back Ba2 plus and Y4 minus. For Ba2 plus, I have 0,1 minus epsilon, epsilon, and epsilon. K dissociation 10 minus 7.8, it will be equal to epsilon square divided by 0,1, as the difference between the concentration and Kd 10 minus 7.8 is more than 100. So epsilon, it's equal to radical Kd over times 0,1. So radical 10 minus 8.8, so epsilon equal 10 minus 4.4 molar, and epsilon is the concentration of Ba2 plus and Y4 minus. As epsilon equal radical Kd 0,1, and epsilon is the concentration of Ba2 plus and Y4 minus. So if I apply over epsilon, which is equal to Kd concentration power half, applying log epsilon, so it's equal log Ba2 plus and log Y4 minus, it's equal to half log Kd times C. If we apply minus log everywhere, I will have P potential of Ba2 plus, which is equal to potential to Y4 minus. It's equal to half PKD minus log C. شو بتشبه هيدي الفورمولا؟ It's similar to pH, which is equal to half pKa minus log C in the case of dissociation of the weak acid. So if you want to try to generalize from this formula, so here the equilibrium of control, it was dissociation of a complex, and both acceptors Ba2 plus and Y4 minus have the same concentration. So in this case, or in such case, we can generalize a formula where the potential of the both acceptors, it's equal to half both acceptors, it's not P donor, okay, P acceptors, so P M equal PL, it's equal half PKD of the complex, which is dissociating, minus log concentration of this complex. And this is a general formula we can apply directly whenever we have the equilibrium of control, dissociation of a complex, and both acceptors have the same concentration in the medium. So if we go back to our exercise, we need to determine the exact composition of all species in the medium. So we have already calculated Ba2 plus and Y4 minus, which is equal to 10 minus 4.4. Ba2 minus, it's almost equal to the concentration 0.1 molar, or 10 minus 1 molar, and they are also asked to calculate PBA, which is equal to minus log Ba2 plus, so it's equal to 4.4. Now I want to consider the coordination titration. And I have here an exercise that I want to solve. Consider 10 milliliter solution of Y4 minus 10 minus 2 molar. I want to titrate this solution with Ba2 plus. So in my beaker I have a ligand Y4 minus, and in my burette I have Ba2 plus. The exercise is to calculate PBA and PY at different volume of Ba2 plus added. So in my beaker I have here Y4 minus 10 minus 2 molar, and in my burette, here I have Ba2 plus also 10 minus 1 molar. The reactant in the medium, the concentration is equivalent to C0F, and the volume V0 10 milliliter. To solve the exercise, you have at the beginning we have to write the reaction. It's a complex formation reaction. So K equal 1 over Kd with 10 power pKd, so 10 power 7.8. So Y4 minus is my big T in the beaker and Ba2 plus in the burette. At equivalence, number of moles are equal, so that we can calculate the V equivalence, which is equal here to 1 milliliter. Now we'll fill the table. As we have the same stoichiometry 1,1 for big T and small t, so we have initially C0F, C0 tau F. For tau less than 1, Ba2 plus is negligible. For tau equal 1, both reactants are negligible, and Ba2 minus is equal to C0F. For tau more than 1, Y4 minus is becoming negligible, and we have in the medium Ba2 plus and Bay2 minus. If we wanted to determine the formula of Py and Pba, for tau less than 1, we have in the medium Y4 minus. So Py, it's minus log the concentration of this Y4 minus. So minus log C0F 1 minus tau. For Ba is negligible. So to determine Ba, we have to use Kd, or we can apply directly like pH. Pba equal pKd plus log acceptor Y4 minus divided by donor Bay2 minus. If we put each concentration by its value, so we have C0F 1 minus tau for Y4 minus, C0 tau F for Bay2 minus. We eliminate C0F, and thus we will have a formula of Pba as function of tau. For tau more than 1, Y4 minus is negligible. So to determine y, we have to use Kd, or also we apply Py equal pKd plus log acceptor, which is Ba2 plus, and donor Ba2 minus. We put each concentration by its value. So we have thus a relation between Py and tau, or we will get Py as function of tau. For Ba, we have after equivalence Ba2 plus is in excess in the medium, so we have the concentration of Ba2 plus. Thus Pba is equal to minus log C0F and we have a relation between PBA and tau. Each formula, I will give a number for each formula. Just if I want to use it back, I can call the formula by its name. So we have 4 formulas. For tau equal 1, we have in the medium BAY 2 minus. So the equilibrium of control is a dissociation of this complex BAY 2 minus, giving BA2 plus and Y4 minus, and K it's equal KD. So we have C0F minus epsilon F for BA2 plus Y4 minus, same concentration. So as we have the equilibrium of control is a dissociation of the complex, and both acceptors have same concentration. Akid, if I want to neglect epsilon F, I have to verify that C0F it's 100 times bigger than 10 minus 7.8. So as it's dissociation of complex and acceptors are of same concentration, PBA equal PY, so P acceptor 1 equal P acceptor 2, equal half PKD of the complex BAY2 minus log concentration of this complex. We put each parameter on its value, and we will have PBA equal 4.92. For each volume, we'll determine the value of PY and PBA according to the formula that we have already developed. Also here, if we compare or if we look on the volume values, we have 0.5, which correspond to half equivalence. Half equivalence we have in the medium the reactant Y4 minus and its product BAY2 minus having same concentration at half equivalence. So BA will be equal to PKD at half equivalence. Okay, to have PBA equal PKD at half equivalence, it depends on what we are looking for. I'm looking here for PBA, BA2 plus, it's coming from the burette, okay? And Y4 minus is the reactant in the medium, in the beaker. So I have my Y4 minus and the corresponding product, which is the BAY2 minus. So it depends what I'm looking for or what I'm calculating. So if I'm calculating PY and Y is in the beaker, I have concentration of Y4 minus, so it's independent of PKD. So at half equivalence, مش دغري I say as it's half equivalence, so PY equal PKD. I have to determine why it's a reactant in the beaker or reactant in the burette. If it's reactant in the burette, so each time I add from the burette, this product or this reactant get consumed by the reactant in the beaker, so it's negligible. And as its value is negligible, so I have to determine this value from KD, and thus I have relation between PBA and PKD. So for half equivalence or at half equivalence, I have the concentrations are equal, thus PBA or P of the reactant coming from the burette is equal to PKD. Okay, so we have to pay attention which P we are looking for, P of the reactant in the medium or P from the burette. Now I want to consider another titration exercise. I have 100 milliliter solution of copper 2 plus 10 minus 2 molar and A3 minus 10 minus 2 molar. So I have initially in the beaker two reactants, U2 plus A3 minus, and I titrate the solution with Y4 minus. The question is to determine PCU at different volume of Y4 minus added. So here we have to look at the beginning what we have in the beaker. So as I have in the beaker CO2 plus and A3 minus, CO2 plus metal A3 minus ligand. So before starting the titration, this metal and ligand can make reaction. So we have to pay attention on this point. لأنه before starting the titration, I have to verify if there's a reaction between the reactant given in the beaker or not. Okay, as here I have, as I said, metal and ligand. So before starting my titration, this metal and ligand will form a complex CuA minus. Formation of the complex, so K equal 10 pKd. CO2 plus, I have 10 minus 2 molar, 10 minus 2. At equivalence, both are negligible. And I'm forming CuA minus. So as I'm at equilibrium, I have in my medium CuA minus, 10 minus 2 molar. This CuA minus at equilibrium, okay, it will be titrated by Y4 minus, but this CuA minus, as there's no more other reaction before starting the titration, so I have equilibrium of control, which is the dissociation of this complex. As this equilibrium of control is a dissociation of the complex, and both acceptors have same concentrations, so I can apply the formula of P acceptors. So PCU equal PA equal half pKd of my CuA minus complex minus log concentration of this complex. So I put pKd on its value, and I have PCU equal to 7.3. Okay, so here we have to pay attention. If we calculate PCU from the concentration of Cu اللي هي 10 minus 2, يعني PCU equal 2, it's not correct, okay, because Cu2 plus react with with A3 minus, forming the complex CuA minus. Now after making the system, or making the reaction in the beaker and getting the equilibrium and having CuA minus in the medium, now I can start my titration. So starting the titration, I have in the beaker, and in my beaker I have CuA minus, and the reaction type, I have two ligands, Y4 minus or A3 minus. So these two ligands will exchange Cu2 plus. As they will exchange Cu2 plus, so my scale will be PCU scale. I put both couples over the scale. I have in my medium CuA minus and Y4 minus. So my reaction will be between the most acceptor and the most donor, between CuA minus and Y4 minus. Here over the scale, the couple is CuA minus and A3 plus. A3 minus, not Cu2 plus. So my reaction, it's an exchange reaction of the copper 2 plus the metal between two ligands. K of this exchange reaction is 10 power pKd acceptor minus pKd donor, which is equal to 10 power 6.2. As it's a titration reaction, so we have to precise big T and small t, and we have to determine the volume at equivalence, which here is equal to 10 milliliter. Then for tau less than 1, Y4 minus is negligible, and we have the concentration for all species in the medium as function of tau. For tau equal 1, negligible, both reactants, and all C0F of CuA minus is becoming A3 minus. For tau more than 1, the reactant in the beaker is becoming negligible, and we have the other concentration. Now we have to determine the formula as function of tau. For tau less than 1, I have in the medium CuA minus and A3 minus, donor acceptor of the same couple, like for acid base, donor acceptor of the same couple, so pH equal pKa plus log acceptor over donor Henderson. Here is the same, as I have donor and acceptor of the same couple. So here why I write PY, oh yeah, PCU, Okay, so PCU, excuse me, PCU equal PKD of the couple CUA minus the couple existing in the medium CUA minus plus log the acceptor A3 minus divided by CUA minus. If we put A3 minus CUA minus by each one by its value, we'll have formula of PCU as function of tau. Now for tau more than 1, CUA minus in the beaker becoming negligible. So we have here the couple Y4 minus, and which is in excess, and the product CUY2 minus. So to determine PCU, also PCU depends on the couple coming from the burette now. So it's equal to PKD CUY2 minus plus log Y4 minus acceptor over donor. If we put the concentration, we'll have relation between PCU and tau. For tau equal 1, I have in my beaker CUY2 minus and A3 minus, acceptor of a couple and donor of another couple, and having common domain on the scale. So I have minor reaction, which is the inverse of the dominating reaction. So K equal 1 over K, 10 power minus 6.2. CUY2 minus C0F minus epsilon F for the product. Here at equivalence, all PCU or PCU of all couples are equal, like pH of all couples are equal. So if we put PCU of each couple and then I make the addition of both couples, I will have PCU as function of PKD of both couples and log acceptors over donor for each one of these couples. This formula, it's similar to the pH formula, which is equal to half pKa plus pKa plus half log acceptor over donor of the first couple times acceptor over donor of second couple. Okay, here I have plus half log. So we have here PCU as function of half PKD plus half log acceptor over donor of the first couple times acceptor over donor of the second couple. We can generalize this formula. We have, if we have exchange reaction of metal between two ligands at equilibrium, P of the element exchange, so here P of M equal half PKD plus half log acceptor over donor times acceptor over donor. Same if we have exchange of L between two metals, so PL equal half PKD plus half log acceptor of first couple time, over donor times acceptor of second couple over donor. This formula could be applied directly. If we go back to our exercise and we put each concentration and each PKD on its value, and we will have PCU equal 15.7. As we have equilibrium of control between acceptor of a couple, donor of another couple, same concentration, so the product will have also the same concentration. So acceptor 1 equal donor 2 and acceptor 2 equal donor 1. So PCU at equivalence equal half PKD plus PKD. Also I can generalize. If I have in the medium acceptor of a couple, donor of another couple, having same domain, so there's no more dominating reaction between these two reactants, but I have minor reaction, I can apply directly the general formula of here, if like PCU, so it's equal half PKD plus PKD. If I have different concentration of A3 minus and CUY2 minus, so the product also will be negligible. So PL or PM equal half PKD plus log acceptor over donor. If we go back also to the exercise, we have different volume. We want to calculate PCU at these different volumes. If we look at 5, it's half equivalence, 10 it's equivalence, and 20 it's double equivalence. So at half equivalence, I have in my medium, I have the reactant CuA minus and its a product. Have equivalence, we have same concentration, so Py equal pKd of the reactant present in the beaker, so 12.6. At double equivalence, I have the excess of Y4 minus in my beaker and the product CuY2 minus. So here I have a double equivalence 2 minus 1, so PCU equal PKD. For the other volumes, you can use the formula and calculate the value of PCU. If we draw here the variation of PCU as function of Y at different volume, the curve is increasing, and we have the disappearance of CuA minus and formation of CuY2 minus. The intersection at 50%, if we project, it will be the half equivalence. So if we project on the curve of PCU and then on the scale of PCU, we will get the pKd of the couple in the beaker. And if we will continue to the double equivalence and we project also on the scale of PCU, we will get the pKd of the reactant decreasing from coming from the burette. Here the curve is increasing because the curve is increasing because as I have in the medium CuA minus, and CuA minus is a donor, so it's similar to the acid. The curve will be increasing. But if I have in my beaker Y4 minus instead of CuA minus, like in this example, the curve will be like base acceptor, it will be decreasing. Thank you.